In this video, we're going to look at how to sketch parametric equations. And when we're looking at a parametric equation, we're actually introducing a third variable, and we're going to use two equations to represent our graph. For an example, we could have x equals 3 minus 2t to represent our x coordinate, and then we could use y equals 2 plus 3t to represent our y. So here, the third variable that we're introducing, t, is called our parameter. And a lot of times we're going to think of that variable as representing time. And we can say after a certain amount of time, whether it's 1 or 2 seconds or 2 or 3 minutes, whatever t is representing, then we can determine where is the x going to be located after so much time has passed. And we can do the same thing for the y coordinate. After that amount of time, where is the y coordinate going to be located? So if we want to sketch the graph, we can simply, easy enough, just make a chart, and we can use the variable t to find what x and y is going to be. Now, since t is representing time, we might think, well, let's start with letting t equal 0. So if no time has passed, we're simply going to plug 0 in for t. So if we plug 0 in up here for t, we're going to get 3 minus 2 times 0. So that's going to be equal to 3. And if we plug 0 in over here, 2 plus 3 times 0, your y value is going to be simply equal to 2. And we can go then to, say, t equals 1, and maybe that's representing 1 second. So 3 minus 2 times 1, so that's 2. So 3 minus 2 is equal to 1. And then for the y value, plug again 1 in for t, so 2 plus 3 times 1, so that would be equal to 5. And let's say after 2 seconds, where is the coordinate going to be? Well, 3 minus 2 times 2, that's 4, so that would be 3 minus 4 is a negative 1. And then we get 3 times 2 is 6, plus 2 is equal to 8. So let's see what happens if we were to actually plot these points. So now we have x is 3, 2, x is 1, 5, and our x and y is negative 1, 8. So if we actually plot these points, and we'll just make a little graph here. So we're looking at the x and the y. So when x is 3, our y value is 2. So we're over 3, up 2. When x is 1, our y value is 5. So x is 1, y is 5. And I'm out of space here, but if our x value is at negative 1, we're up here at a positive 8. And we can see that we're going to end up with a straight line. Now, if we were to pick some other values, for example, let's say that what happens if I started picking negative value for t? Well, we plug a negative in, we get 3 minus 2 times negative 1. So negative 2, negative 1 is a positive, so that's going to be 3 plus 2, which would be equal to 5. And then over here we would get 3 times negative 1, so that's 2 minus 3 would be a negative 1. So if we plot the point 5, negative 1, so over 5 and down 1, we're still going to end up with the rest of our straight line. So here it's going to depend on the values that we're going to let t represent. Sometimes you may not let t be negative, and sometimes it's okay for t to be equal to a negative value. Now let's look at how we could put this set of equations into our calculator. Now first on the calculator, we're going to have to go into the mode function here. And we want to scroll down here to where it says function, and we want to highlight PAR over here. That's representing parametric. So we're going to highlight parametric. And notice now if you hit the y equals key, it's no longer y equals, it's x equals and y equals. So that allows us to type in our two equations. So the first equation is 3 minus 2t. So it's 3 minus 2. And we want to use the same variable button up here that has an x, a t, or theta, and n. So we're just going to hit the variable key. And because we're in parametric mode, Notice the variable is not going to turn up here as an x, it's going to turn up as the letter t. So 3 minus 2t. We hit enter, we can enter the y equation, which is 2 plus 3t. And if we go to the window, notice here we have t minimum starts at 0, and we can leave it there. Our t max, and what did we do before? We went from 0 to 2, so let's try that and see what happens. So t minimum is 0, t max is 2, and then you have something here that is called the t step. And what that means is I'm going to type in 1. What the step is representing is that, notice here, I went from 0 to 1 and then 1 to 2. So here we're increasing the value by 1, and that's what is happening here. So our step means we're going to start at 0, then we'll go to 1, then we'll go to 2. So if we do this, and if we hit graph, and actually before I go to graph, I want to go up here, back to y equals, and move the cursor, use your arrow key to move the cursor in front of the X, and I want to keep hitting enter until I see this little open circle with a line, because that way when we hit graph, it's going to trace out the graph. So now when I hit graph, notice it looks like our graph starts here and it's going from this bottom right to the top left corner, and it's only plotting the points when t is 0, t is 1, and t is equal to 2. So that's why we only have this one little segment. If we go back to the window function, and if I type in -5 for the minimum, and for the maximum type in a +5, and then if I go to graph, notice we get more of the function graph because we're looking at a bigger interval. So that's one thing you need to be aware of here in the parametric mode is your t minimum and t max, and also this t step. In a lot of cases, I may make the t step 0.1, but you don't want to make it too small, otherwise your calculator is going to sit there and plot a whole bunch of points. And let's see what happens if I actually type in 0.1 here to see what it does. Notice it's moving a little bit slower because it's plotting all the points with 1/10 of an increment. So it's going to go much slower, but we can see the path of the graph. So if I was to copy this, what that is telling us here and we can see this matches up to what we did when we looked at graphing this equation by hand. But now we notice that this graph, when we were plotting the points, even what we did over here ourselves, the direction of the graph was going this way. So here, this is called the orientation, and that simply means as t, the time increases, what direction is the graph going? Well, and that's why I said if you use that little open circle in the calculator, you're going to see that as the value of t increases, your graph is going to be going upwards in this to the left direction. So that's what it means when it says what is the orientation as your t value increases, which way is the graph going? Okay, let's try another example. Let's say that we have the equation x equals t plus 2, y equals t squared. And in this case, they actually give us a restriction for the value of t, and t is going to be -3 less than or equal to t is less than or equal to +3. So basically that says we're only going to look at values of t that go from -3 to +3. Now, once again here, we could easily make our own chart for values of t, then x, and find the values of x and y. So if that's the case, we would simply start with a -3, then we could plug in -2, -1, 0, 1, 2, and 3. And we could certainly easily do that. Or if we go to the calculator, I'll go into y equals and clear out the previous equations. And the first one here we have is t plus 2, and then we have t squared. And now I'm going to go to the window, and we want to type in -3 for the minimum and a +3 for the t max. And for now, I'm just going to leave the step at 0.1. And when we go to graph, notice the direction of the curve. It's going this way, and we end up with a parabola. So if we paste that here, we'll have our graph. And once again, we want to identify the orientation. And as this was being traced out, it's going to the right. So this is we would use little arrows here to represent the orientation. So here it would be from left to right would be the orientation. The example above, notice it was going here. It's going from the right side to the left. So we could think of this as going right to left as far as the orientation. Now, again, we could easily plot the points and we would get the same thing. So as we start at -3, now keep in mind this is the t value. We have to use that to get the x and y value. So if we plug the -3 in up here, we get -3 plus 2 would be a -1. And if we plug a -3 squared, that would be a +9. So that tells us at a -1, 2, 3, then our point is going to be up here at a +9. So from this, we can see that by introducing this third variable t for time, it's just another way to actually represent where is the graph going to be located after a certain amount of time has passed.